In this video we're going to work out the limit of this multivariable function. So the origin is right here, and this is your x-axis, this is your y-axis. Along x equals 0, so along this plane, well, you would put 0 into the x, you would put 0 into here. This whole thing here will then become this. So along that plane the limit equals 0. Now along y equals 0 plane, along the y equals 0 plane, that would be this plane here. Along this plane, this whole, well, you would put 0 into the y, put 0 into the y. This whole thing here will then become this. Along this plane the limit equals 0. So we suspect that our limit is 0. Now if the limit truly exists, if you get the limit, take away our suspected limit of 0, then take the absolute value, then it should equal 0. It should equal 0. So let's concentrate on this. Well, when you get this, take away 0, it's just this. And so this whole thing here will then become this. We know that when you take the absolute value of something, it's always going to be greater or equal to 0, because our aim here is to trap this in between 0 and something, and then use the squeeze theorem to show that the limit, if the limit exists, we can show the limit equals something. So we are currently here looking at this fraction. If we can make the denominator smaller, then the whole fraction would be bigger. So if we can make the denominator smaller, so looking at this, if I turn this 3 into a 2, then the denominator will be smaller. Well, if the denominator is smaller, then the whole fraction, this whole fraction, will be bigger or equal to this fraction, because here I'm making the denominator smaller. I'm making this whole denominator smaller. If the whole denominator is smaller, then the whole thing will be bigger than this thing here, bigger or equal to. So we are currently here at the moment. So now you can see that this is a 2, this is a 2. Factor out the 2, that will then give you this, and then remember, square root of ab equals square root of a square root of b. So here, one thing multiplying another thing, so that's the same as square root of 2, and then square root of this whole thing here. So that will then take us to here, and then notice that this is positive, this is always positive, this is always positive. So you taking the absolute value of the whole thing is the same as you just concentrate on making this y, because this is the only thing that could be negative. So doing the absolute value of the whole thing is the same as you just concentrate on taking the absolute value of y, and then because the rest will always be positive. So this thing here is the same as this thing here, and then hang on, and then you x squared is the same as absolute, x squared is going to be smaller or less than this thing here. X squared here you can turn into absolute value of x, and then times absolute value of x. But then the absolute value of x is the same as x squared y squared. So that's the same as this thing here. And then you can merge these two together. So that will then give us this. So this whole thing here will be bigger or equal to this thing here. And then now looking at this, the function that we were interested in was this. Well, this thing here is always going to be less than or equal to this thing. This thing here will always be bigger or equal to 0. So now we can take the limit of all three. So take the limit of this, take the limit of this, take the limit of this. That will then take us to here. The limit of 0 is 0. Here nothing really breaks down as x and y heads towards 0, 0. Nothing really breaks down. It breaks down if you have something like this divided by something like 0 or x. Well, if you divide by 0, it breaks down. But here, nothing is being divided by 0. So here, nothing really breaks down. It will head towards the origin. This whole thing here will head towards 0. So that will then take us to here. Well, we don't know what this this limit is doing, but we do know that it's trapped in between 0 and 0. So by the squeeze theorem, the limit of this must be 0. Okay.